So we're continuing to take a look inside of the Kibo module, where you can see Kevin Ford there on the left and Tom Marshburn on the right, continuing to conduct this spheres experiment, working with and talking to students down at MIT. Hundreds of high school students organized into over 20 teams competing with these spheres, satellites, spheres standing for the synchronized position, hold, engage, reorient experimental satellites. Are those small bowling ball shaped objects. They're completely self-contained. They have computer processors located inside, and then that are then controlled by these algorithms that these students write to try and accomplish tasks relevant to spacecraft, such as rendezvous and docking and formation flying. Again, this spheres activity, a great opportunity for high school students, providing them the ability to act as ground controllers, more or less, conducting real research in space while utilizing these spheres satellites. As part of this competition, student teams around the country are encouraged to submit proposals and then implement their written programs and algorithms in various 2D and 3D simulations. They then have the ability to test out all of their codes and sims on ground demonstrations at a facility located on the MIT campus. They have a flat floor facility which can help mimic some of the frictionless activities of microgravity. And then following the success of those simulations and ground testing, they eventually get selected for this flight test, which you can see taking place right here inside of the Japanese Kibo module.
All right, that was pretty wild business right there. And here are the numbers. Are you ready to copy?
Yeah, we're ready.
Okay, blue satellite returned 141, 141. Red satellite returned at 906, 96.
All right, we copy blue 141 and red 96. MIT's crunching the final winner. In the meantime, we can start to set up for Group B tests and load those programs on the satellite.
Okay, here we go.
And we'd like to commend Tom on his fancy footwork.
Yeah, that was nice.
And Kevin, back with you, hot off the presses from MIT. The European champion is Kathy in Space.
Wow, that's fantastic. You know, congratulations to everybody. Everybody's champions, frankly, to be in this competition. So congratulations to everybody, and special congratulations to Kathy in Space. That's pretty special. That was fun to watch. Program is loading.
And we copy all. Sounds good. Thank you.
So Ford and Marshburn just wrapping up the European section of the competition. They'll be continuing with some U.S.-based class competitions up next.
Let me see how we're doing here.
Commander Ford taking a peek in the camera there. This Sphere Zero Robotics, a very unique and valuable opportunity to get these students directly involved and interested in all of the STEM fields, those being science, technology, engineering, and math. These students participating in real-world engineering activities right now.
You can go ahead and pause. That's fine with us.
Having their the products that they've developed being used directly on board the International Space Station. Meanwhile, back here in Mission Control Houston, we're heading to the end of this Friday edition of International Space Station Update. Just one quick programming note for you. Immediately following today's broadcast, we'll have the NASA video file. That'll be up next here on NASA TV at 11 a.m. Central Time, 12 p.m. Eastern. Meanwhile, the team here in Mission Control, the Orbit 2 squad, continuing to look over all their systems as they're led for one final time by NASA Flight Director Paul Dye. This will be Paul Dye's last shift of an illustrious career as a NASA Flight Director. And from all of us at NASA, we would just like to thank him and wish him the best of luck in the future as he moves on to greater endeavors. For now, though, we will go ahead and end this week's International Space Station Update and sign off. This is Mission Control Houston.